We have discussed a number of circuits with the op amp and the ideal op amp. There is a crucial detail which we have omitted. The op amp is a device that needs power. Okay. It has to be powered by some voltage source for it to operate. Okay. So, that aspect we have completely omitted. In this lesson, we will take a basic look at it. It turns out that the power supply voltages that you use set certain limits to how much the output voltage can be and still have the op amp operating as desired. That is like a voltage controlled voltage source with a very large gain A naught or as an ideal op amp. Okay. That is what is meant by saturation, and we are going to discuss that in this lesson as well. So far, I have been using this symbol for the op amp with 3 terminals, non-inverting terminal, inverting terminal and the output. Now, this it turns out is incomplete and we need 2 more terminals to which we can attach the power supply. Okay. So, typically this is labeled V plus and this is labeled V minus. Okay. And you connect some power supplies to it. And a typical scenario is to use 2 separate voltages VDD and VSS to supply a positive voltage to the V plus terminal with respect to ground and a negative voltage to the V minus terminal with respect to ground. Now, this is not strictly necessary. You could use a single voltage source, but in most of the standard op amp applications 2 power supplies are used. So, we are going to stick to that. Okay. And it is also quite usual to not show the power supply voltage sources like this, but to simply draw a picture of this sort. Okay. So, this is the V plus terminal, that is the V minus terminal, and it simply indicated here that it is VDD and VSS. This means that there is a voltage source of value VDD connected between this terminal and ground, and this means that there is a voltage source of value minus VSS connected between this terminal and ground. This should be minus VSS. Okay. So, now what is the effect of this on our amplifier or any circuit we build? It turns out that the output voltage V naught of the op amp can swing between VDD and VSS. Okay. In fact, it cannot go all the way up to VDD or all the way down to VSS. Typically, the allowable range for V naught is somewhere between VDD and VSS. Okay. So, let me take some typical values from old general purpose op amps. VDD could be 12 volts and minus VSS could be minus 12 volts. Okay. So, we have 12 volts and minus 12 volts, okay. And the output could be swinging between, let us say, 10.5 volts and minus 10.5 volts, while still behaving like a voltage controlled voltage source. For the op amp to behave like a voltage controlled voltage source, some limits have to be placed on the output voltage V naught, and that limit is set by the supply voltages which are connected to the op amp. Okay. In reality, the limits on V naught will be a little less than the difference between the power supplies. Okay. That is, it cannot go all the way up to VDD, nor can it go all the way down to VSS. Now, in absence of any information about the details of the op amp, frequently for solving problems, we think of the range of V naught as being this entire range between 12 volts and minus 12 volts, that is between VDD and minus VSS. Okay. So, this is the allowable range for V naught. Okay. Now, in addition to this, if I call the input voltages as V 1 and V 2, each of V 1 and V 2 has to be also limited to some range, and again in absence of any further details about the op amp, if we are not talking about a specific op amp, but we are solving problems in general, then we can think of V 1 and V 2 also being limited to the same range. Okay. So, this is the range for V 1 and V 2. Remember, when the op amp is placed in negative feedback, this V 1 and V 2 will be very close to each other. Okay. But each of them can take on any value, right, and that value is limited to this. When I say limited to this, limited to between VDD and minus VSS, what I mean is, if V 1, V 2 and V naught are limited to these values, the op amp behaves like an ideal voltage controlled voltage source with a very large gain. Okay. And frequently it can be approximated by the ideal op amp, in which we say that the gain is infinite. Okay. In other words, if I take an op amp with gain A naught and plot V naught versus VD, it will be a straight line, because we model it as a linear voltage controlled voltage source, and the slope will be very large. Okay. In fact, if I use the same scale for x and y axis, then it will be pretty much a vertical line, but I want to show some slope. So, I will show it like that. Okay. And the slope of this is nothing but the gain A naught, but it will not continue indefinitely like this, assuming that the supply voltage is VDD and the lower supply voltage is minus VSS. Okay. On the upper side it will be limited to VDD, and on the lower side it will be limited to minus VSS. Okay. So, this is the characteristic of the op amp. Now, if we are talking about an ideal op amp, there are many cases in which we consider the slope here, the gain of the op amp, to be infinite, but still we want to judge the effect of having power supplies which are not infinitely large. Okay. So, I will show it like this with A naught equals infinity. Okay. In this case, if I plot V naught versus VD, I will get a straight vertical line, but it will saturate at VDD and minus VSS. So, these regions here, these are known as saturation regions. Now, if we want the op amp circuit to behave in the way we analyzed it before, that is, when it is placed in negative feedback, its input voltage must be very small or even 0 if we consider the limiting case of A naught being infinity. The output voltage must not reach either of the limits. Similarly, the input voltages V 1 and V 2 individually must not reach the limits. Okay. So, these are some limits on the input and output voltages of the op amp, so that it behaves in the way we expect it to, that is as a very high gain voltage controlled voltage source. Okay. Now, what is the effect of this on a circuit? Let us take a circuit that is very familiar to us. Let us say I have 9 kilo ohm and 1 kilo ohm. This is a non-inverting amplifier, and let us say I assume that the op amp is ideal, that is its gain is very large, tending to infinity. Now, I use supply voltages of 12 volts and minus 12 volts. Okay. So, if I have V I here, I will have 10 times V I over there. You can easily calculate that the gain of this amplifier is 10. Now, as I said, 10 V I, whatever the output voltage is, has to lie between the upper supply and the lower supply, which is 12 volts and minus 12 volts. That means that for this amplifier to work as expected, for it to work like an amplifier of gain of 10, V I has to be limited to 1.2 and minus 1.2 volts. Okay. Because if you exceed these limits, let us say you apply a V I of 1.5 volts, from the gain of 10 that you expect for this amplifier, you would expect that the output would be 15 volts, but the output cannot be higher than this power supply. So, it will saturate at 12 volts. Okay. So, if the input voltage is between these limits, V naught will be 10 times V I, and if V I happens to be smaller than minus 1.2 volts, the output will saturate to the negative saturation level of minus 12 volts, and if V I happens to be more than plus 1.2 volts, V naught will saturate to the positive saturation level, which is plus 12 volts. So, clearly in these cases it is not behaving like an amplifier at all. Okay. Also, let us say you apply a time varying signal. The standard signal to analyze circuits with is a sinusoid, and let us say the peak value is V p. At the output, we expect that we will have a sinusoid of peak value 10 times V p, because the output is simply 10 times the input. And this will happen if this 10 times V p is within the saturation limits. Okay. So, let us say V p is 1 volt, okay. Then this 10 times V p is 10 volts, and the saturation limits are really at plus 12 volts and minus 12 volts. Okay. The signal swings safely between them, but instead let us say V p is 1.5 volts, and at the output of an amplifier with a gain of 10, I would expect sine wave like this, whose amplitude is 10 times V p, which is 15 volts. Okay. And a sine wave is symmetrical. So, on the other side, I would expect the peak to be minus 15 volts. Okay. But this is not going to happen. What will happen is that because the upper limit is 12 volts and minus 12 volts, the output will follow the expected one as long as it is within 12 volts and minus 12 volts, and it will saturate there. Similarly, it will come down, it will saturate there, and so on. So, clearly this is not a good amplifier, because the output shape does not resemble the input shape anymore, and it is not, the output is not simply 10 times the input. Okay. So, whenever you use an op amp, you have to also make sure that all the voltage levels, the relevant voltage levels of the op amp, the individual input voltages V 1 and V 2 and the output voltage V naught are within the specified limits. In absence of information about a particular op amp, you assume that the limits are equal to the supply voltages. Okay. Now, I won't discuss this in further detail. It is very common to use equal values of VDD and VSS, that is, use symmetrical supplies, where the upper supply voltage is 12 and the lower one is minus 12, as I showed in these examples. But it is not necessary for them to be equal. You could have plus 12 volts and minus 6 volts. That will only change the limits you can have for V 1, V 2 and V naught. And similarly, it is possible to eliminate the second supply voltage altogether and have a single supply voltage. that is the lower voltage will be 0 volts, you connect it to ground, and the upper voltage is whatever it can be. Okay. It could be 12 volts and 0 for instance. So, that is known as single supply operation of the op amps, and that is perfectly possible. All you have to make sure is that V1, V2 and V0 in your circuit fall only between 0 and 12 volts. You cannot go negative. Okay. And it is quite easy to arrange that. I will not go into those details here, but it is possible to operate op amps with a single power supply voltage as well. Okay.